Hello guys, welcome back to Foolish Engineer. The quick answer for what is the difference between a high voltage BMS and a low voltage BMS is that the high voltage BMS manages huge battery packs with hundreds of volts, typically in 400 volts or 800 volt range, while a low voltage BMS handles smaller pack under 60 volts, which are used in small two-wheelers EVs. The difference is basically scale, safety demands, and complexity. Well, let's go more deeper into this. One of the key reasons I started this YouTube channel is to bridge the gap between the outdated Indian education system and actual skills needed in the industry. Well, if you're a student, you can use and learn an industry leading EDS software, Altium, for free by using its student lab program, which narrows down this gap. You just need to use your university email to enroll, and you get a full student license, a full PCB design course, and a certificate recognized by top Indian core electronics industries. Altium isn't just one PCB design software, but it is a whole platform of capabilities for electronics design. I've personally used Altium since the start of my electronics journey, and I honestly recommend it. It's a fantastic way to enhance your skills and increase your chance of landing a job in a core electronics company. So don't miss this golden opportunity. So far, we have seen the BMS, which is usually used in low voltage, where few cells like 10 to 12 are used in series. But when we talk about big Teslas, BYD, and Tata EVs, they use not just hundreds but thousands of small lithium ion cells. And BMS has the job to take care of each and every cell. That's where high voltage BMS come into picture. The concept and working are the same as we saw in most of our old videos, but the architecture and the internal structure is designed such a way that this tiny piece of electronics can take care of these many cells, which keeps them balanced and protected from the abuse. An HVBMS oversees the battery packs, typically above 60 volts, often hundreds of volts, and multiple cells in series. These high energy packs can deliver serious power of around 400 volt Tesla packs or an 800 volt Porsche EV pack. So the high voltage BMS's job is to maximize the performance while preventing disasters. So this video series will bridge the gap between the fundamentals we have covered already and the big picture system design needed for high voltage batteries, so that we'll understand how those big battery packs are managed. To think in a real life analogy, if a regular low voltage BMS is like a class teacher or safety monitor in a small classroom, an HABMS is the headmaster of a large chaotic school. It has to track a lot of students, in this case cells, enforce stricter rules like voltage and temperature limits across a large area, and be ready for emergencies like high voltage timeouts if things get out of hands. All the fundamental tasks are similar: monitor, protect, balance, and report. But in an HVBMS, everything is on the high class to handle higher stakes for high voltage. For example, an HVBMS in an electric vehicle pack will continuously monitor each cell string's voltage, peak current, and pack temperature, and will shut things down if any cell or the whole pack goes outside safe limits. It will communicate with the vehicle, typically via CAN bus, to share battery status and even talk to motor controllers or chargers about how much power it can safely flow. Well, the core mission is the same, but high voltage and low voltage BMS do it bit differently due to their different scales and applications. Let's see the key differences between these. A low voltage BMS typically manages packs from a single cell up to about 48 volts or 60 volts. In contrast, a high voltage BMS handle packs above 60 volts, often 100 to 800 volts. The HVBMS must keep all those cells in check and balanced, whereas a low voltage BMS has much smaller cell count to manage. Because of the large number of cells, HVBMS designs are usually more complex and distributed. They typically use a master slave configuration with multiple slave cell monitoring units, each measuring a group of cells and reporting to a central master control. This is like having several sub-monitors for each battery module feeding data to a headmaster or a BMS bin. A low voltage BMS, on the other hand, is just often one single board handling all cells directly since there are fewer cells and lower voltages. A single microcontroller or BMS IC can often manage them. The high voltage system's communication is also complex like its structure. The BMS modules often talk to each other and master via an isolated daisy chain type of communication, and then to the outside world as well. The low voltage BMS might not need such big communication for a simple pack. Sometimes it's just like one board solution with maybe a basic SPI or I2C output. High voltages introduce greater safety risks. There is a literal shock hazard and higher chances of arcs or fires if something goes wrong. As a result, HVBMS includes very strict safety measures that low voltage systems might not require. For example, an HVBMS will have galvanic isolation in key places. We can't just wire a 400 volt pack directly into a microcontroller without isolation barrier, unless we like smoke. And it often incorporates insulation monitoring to detect any leakage or ground faults in the high voltage system. The low voltage BMS doesn't usually need such fancy isolation. The voltages are low enough to be safer, and the system can often share a common ground with its devices. An HVBMS manages a pack that can dump huge power. It has more robust protection mechanism. Both high voltage and low voltage BMS will do over voltage, under voltage and over current protection. The difference is how far they can go. For example, a high voltage BMS often adds more advanced thermal management integration. Thermal management in a small pack might be just a temperature sensor to stop charging if it's too hot, whereas an HVBMS might actively manage a cooling system for the battery. Also, fault tolerance is different. For example, in high voltage BMS, multiple sensors or backup communication path is used in electric vehicles, where safety is the biggest priority. If you found this video useful, give it thumbs up, hit the subscribe button and stay tuned for more exciting content.